Today you're going to be taking notes over Earth's structure. This is Unit 7, Lesson 1. During this unit, we will learn about Earth's layers, tectonic plates, as well as the rock cycle. Okay, so please put your first and last name on your Cornell note sheet. Please put today's date and the topic, Earth's structure. Okay, so let's go ahead and set your Cornell note sheet up properly. Notice that the word Earth is in bold. Please make sure that that word is on the left in your column. We all know that Earth does have several distinct layers. And if you take a look at the graphic, you will see that the inner core, outer core, mantle, crust, and atmosphere is labeled. Okay, so Earth is made of several distinct layers. Okay, so the outermost layer of the Earth is called the crust. And this is made up of the continents and the ocean basins. I know sometimes we are just tempted to think that the crust is just, what we can see, so what we walk on or even mountains. But also remember that the crust is made up of what we cannot see. So the crust that is deep below the ocean, it's on the ocean floor, that is also the crust. In this graphic on the left, you will notice that there is this line that runs from the north to the south pole. Take a look at what continents these are and identify them in your head. Okay, and then notice what ocean this is on the bottom of. Okay, this is called the Mid-Atlantic Ridge, and it's where two plates are pulling apart. And the magma is rising, and because the bottom of the ocean is very cold, it's creating new crust. So essentially, you've got an underwater mountain range being created along this mid-ocean ridge because those two plates are pulling apart. Okay. The next layer is the mantle. The mantle is separated into the upper and lower mantle, which we will get to here in a few slides. But this is where most of the internal heat of the Earth is located. This is where you will find the convection cells that move plate tectonics. The structure of the mantle is very interesting. The top layer of the mantle is kind of solid. And then the bottom portion of the mantle is very hot, and it is it's molten, so it's liquid. And like I said, we'll talk about specifically about that here in a few slides. So the mantle is separated into the upper and lower portion, and it's where most of the internal heat of the Earth is located. Okay, so located inside the mantle are what we call convection cells, and they're very large, and they circulate heat and drive plate tectonic processes. So if you'll think back to our thermodynamics unit, or when we learned about the way heat moves, I want you to think about the word convection and what that means. If you're thinking that it means heat rising and cool sinking, you are correct. Okay, not that anything in the mantle is considered cool, but I guess the hotter substances, they will rise, and the cooler substances will sink, and that creates that movement, that convection, that current. And those are located in the mantle. This graphic is actually really interesting. Here you've got a divergent boundary, a convergent boundary, a transform boundary, and then you can also see where those are labeled here in the graphic. So here on the continental crust, the two plates are pulling apart, and it creates a continental rift zone where basically the Earth appears that it's kind of sinking in and breaking apart. Over here, this is actually really interesting, the trench. A trench is created, at least in this graphic, from the oceanic plate subducting under the continental plate. And so the pressure pushing together as one slides under the other one, it kind of buckles up and it creates almost like a V. Okay, so it creates like a trench. Here, the ocean seafloor is spreading. Okay, so the two plates are pulling apart at the bottom of the ocean. Along these areas, you'll often find volcanoes and things of that nature. Here you've got another subduction zone. Remember, subduction from your vocab means that one plate is sliding underneath the other. Okay, and here you will find, and in places like that, you'll find trenches, you'll find volcanoes, and things like that. Okay. Basically, in that mid-Atlantic ridge, so in the bottom of the Atlantic Ocean where those two plates are pulling apart, this is what's happening. Okay, it's creating a very large underwater ocean or underwater mountain range. Here you've got your convection currents. Okay, so this slide is basically, obviously we know about the core, we know where it's located. There's an inner core and an outer core, and they're made of different things. So the last layer that we're going to talk about is the core. It's separated into the outer core and the inner core. The outer core is liquid, the inner core is solid. The outer core is composed of a nickel-iron alloy, while that inner core is almost entirely composed of solid iron. And you will need to know what the inner and outer core are made of for your unit test. And you will also need to know which one is solid and which one is liquid. May I move forward? No? No? May I move forward? About 30 seconds. Okay, so the Earth is, if you want to put like, in the left-hand column, like how is the Earth separated, that's fine, or you could put Earth again in the left-hand column. So the Earth is separated into layers based on mechanical properties in addition to composition. So I want you to think about what that word mechanical means and composition. What does that mean? The Earth is separated into layers based on mechanical properties in addition to composition. What are mechanical properties? If you're thinking that it's the way something moves, you are correct. Okay? And then composition, that word means what things are made of. So that's how scientists define and differentiate between Earth's different layers. It's determined by how they move and what they're made of. How they move and what they're made of. And you can write that on your Cornell notes if you want to simplify this. Okay, so scientists define those layers or separate those layers based on how they move and what they're made of. And once again, the graphic will show you the different layers of the Earth. Okay, so let's talk about the lithosphere. We've talked quite a bit during this note set about tectonic plates. Okay, we know the Earth's crust is broken into parts, into pieces. We call those plates. And it's actually not only just the crust that is moving during tectonic activity, it's actually what we call the lithosphere. So the lithosphere is made up of the crust and the solid portion of the upper mantle. So that's actually what's moving. It's not just the crust. It's also that solid portion of the upper mantle. And the lithosphere is divided into many plates that move in relation to each other due to tectonic forces. Okay, so those plates, they do fit together like a puzzle. And because they fit together like a puzzle, if there is disruption on one side, there will be equal and opposite destruction on the other. Okay, so you see Newton's laws also coming into play while we study plate tectonics and plate movement. So the lithosphere is made up of the crust and the solid portion of the upper mantle. The lithosphere is divided into many plates that move in relation to each other due to tectonic forces. And that is the lithosphere. Raise your hand if you thought that whenever there was an earthquake that it was only crust movement. Raise your hand if you thought that it was only crust movement. Okay, cool. Well, good. We learned something new today. Okay, so remember that lithosphere is made up of the solid crust. The lithosphere is made up of the crust and that solid portion of the upper mantle. My mistake. Okay, can I move forward?
Oh, I forgot about this.
Okay, so let's talk about the asthenosphere. Asthenosphere, which is quite a mouthful. So the asthenosphere is the portion of Earth that the solid lithosphere floats on top of. Okay? I don't really like the way that first bullet point is written. I probably need to go back and rewrite that. So it is, the asthenosphere is a semi-liquid layer. Okay, it's not a solid like the lithosphere. Okay, and the asthenosphere, because it's a semi-liquid layer, that lithosphere kind of floats on top of it. The asthenosphere allows the lithosphere to move around via convection currents. So remember how we talked about convection currents in the mantle? Those convection currents actually take place in the asthenosphere. So the asthenosphere allows the lithosphere to move around via convection currents. Remember that lithosphere is the crust and that top portion of the mantle. So the asthenosphere is much weaker than the lithosphere because it is a semi-liquid layer. It's also where it's more hot. Okay, so that's where your convection currents that are actually moving the plates are located, in the asthenosphere. Yes. So the mantle is divided into the upper layer and the lower layer. The upper layer is solid, and it's called the lithosphere. And then the bottom part of the mantle is that semi-liquid, and it's called the asthenosphere, and that's where the convection currents actually take place. We probably need to draw that. Can I move forward? Okay, one more slide. Okay, so heat and pressure cause a small amount of melting to occur in the asthenosphere. While still solid, the asthenosphere is able to flow. Okay, so when two plates push together, there are times when one will slide under the other. Does anybody remember what that means? When one is being subducted. Okay, so the plate that's actually being subducted is going into the mantle, and it is being destroyed because it's very hot there, and yeah, basically it gets melted down. So while along that mid-Atlantic ridge, you've got crust being created. Okay, at another plate boundary, you would be seeing subduction, and of the plate would be being destroyed. So it's a very it's a process of creation and destruction, and it's constantly going on, and we feel it in the form of earthquakes. But it's much, much more than that. Thank you for taking Cornell Notes with me today.